Hey everyone, welcome to our next video. In this video, we will learn about the distance time and velocity time graphs. In our previous video, we have learned the concepts of distance, displacement, speed, velocity, and acceleration for an object in motion. Now, let's try to understand these concepts using graphical methods. One such graph is the distance time graph. In this graph, the time interval is represented along the x-axis, and the distance traveled along the y-axis. Let's take one such example. We can extract a lot of information from this graph. The first thing is that it traveled a total distance of 60 meters in 10 seconds. It also tells us about the different stages of motion of the object. The important thing to know is that the slope of the graph at any point tells us the speed the object is traveling at that time. This is because if you take any 2 points on the graph, its slope is equal to the change in distance divided by the change in time, which is the formula for speed. So, in this first section, the object traveled 20 meters in 1 second, so the slope will be 20 divided by 1 or the speed will be 20 meters per second. In other words, as the distance time graph during this period is a straight line, the speed is constant. Meanwhile, the flat line as in this second section, tells us that the object traveled 0 meters in 5 seconds. So, it is stationary, or the speed of the object is 0 meters per second. Next, if the graph gets steeper, the slope or the speed must be increasing, and so this part shows acceleration. While a decreasing slope as in this part, shows decreasing speed or deceleration. Now, one really important point is that while the speed is constantly changing like it is in these last two stages, it's a little bit complicated to find the speed at any particular point. So, if we want to find the speed at 7 seconds, we have to draw a tangent to the curve at that point, because a tangent is a straight line that has exactly the same slope that the graph has at that point where they touch. And, we know that the speed is equal to the slope. Once we have the tangent, we can pick 2 points on the tangent, and dividing the change in distance, which is 20 meters, by the change in time, which is 2 seconds, we get its slope or the speed at that particular point to be 10 meters per second. Finally, let's add one more section to this graph. Inspecting this section, can you guess what's happening here? You can see the distance traveled by the object decreased from 60 to 50 meters, while the time increased from 10 to 12 seconds. The object traveled a distance of 10 meters in 2 seconds, so its speed is 10 divided by 2 or 5 meters per second. But since the distance traveled decreased from 60 to 50 meters, the object traveled in the opposite direction, or else the displacement is minus 10 meters. As such, the velocity of the object during this time interval is minus 5 meters per second. The next graph is velocity time graph. In this graph, the time interval is represented along the x-axis, and the velocity of the object along the y-axis. The important thing to know is that the slope of the graph is equal to the change in velocity divided by the change in time, which is the formula for acceleration. So, in the first section, the change in velocity is 3 meters per second, and the change in time is 2 seconds, so the slope is 3 divided by 2, or the acceleration is 1.5 meters per second squared. Next, the flat section of the graph has a slope of 0 since the change in velocity is 0. So, the object is not accelerating at all, which means that the velocity is constant at 3 meters per second. Finally, in the last section, the velocity decreased from 3 meters per second to 2 meters per second in 2 seconds. So, the change in velocity is 2 minus 3, or minus 1, and the change in time is 2, so the acceleration is minus 0.5 meters per second squared. We can extract one more piece of information from this velocity time graph, which is the distance traveled by the object. To find the distance, we need to find the area enclosed by the graph, since the product of velocity and time is distance. If we want to find the distance traveled in the first 4 seconds, we need to calculate this area. To make it easier to calculate, we can split the area into a triangle and a rectangle. The area of the triangle is half times its base times its height. In this case, it will be 0.5 times 2, which is our time, multiplied by 3, which is our velocity, so 3 meters. Then to calculate the area of the rectangle, we must calculate its base times height. In this case, it will be 2, which is our time, multiplied by 3, which is our velocity, so 6 meters. So, the total area or the total distance traveled in the first 4 seconds is 3 plus 6 or 9 meters. If you want to calculate the total distance traveled in 8 seconds, you need to calculate this area. Try to calculate it and let us know in the comments. Anyway, that's all for this video. If you find it useful, please do share it with your friends or give us a comment down below, and we will see you next time. Thank you.